Engaging with the data you need in the shape you need it is the whole point of this course. So let's dive into indexing and filtering. Hopefully you'll see a pattern emerging. Nickel is very much like SQL. So you'll add a where clause to filter for matching documents. As you might expect, field names are case-sensitive in queries while keywords are not. And a side effect of the flexible nature of JSON data modeling is that each document is potentially different. Couchbase neither enforces nor validates your document schema, so misspelled filters succeed, but with zero results. Later we'll see, though, how to query specifically for where document fields or values are missing, whether for data cleansing or other reasons. Syntactically here, just notice that you can filter for exclusion of a value as well as inclusion, as you might expect. Later we'll survey more about the expression capabilities implied here. Earlier in this course, we compared using a database and a bucket as a top-level data container. We saw that rows and documents are analogous, and how like-named field across documents of the same type are a functional analog to a table column. The implication of this naturally is that a set of commonly typed documents are the functional equivalent of a table, albeit with the flexibility to rapidly evolve your documents in line with a rapidly evolving codebase. Now hold on to this notion of a document type as a way to treat a set of documents like a table. We'll get back to it. You can easily create an index for any field or series of fields within a bucket. Having an index in place dramatically speeds corresponding queries, just as you'd imagine. They're continuously maintained, of course, so you can drop them when they're no longer needed, either using this syntax or visually in the UI. At scale, of course, an index in any system is a non-trivial artifact to build and maintain, so it makes sense to build them as narrowly as makes sense for the data that you actually need to retrieve. Filters can be added to reduce overall index size and improve performance along the way. You can narrow indexes by one or as many additional filters as are appropriate. Of course, if you index with multiple filters, queries will need to be correspondingly filtered to make use of this index. The query planner doesn't care about the sequence of your query filters, though, just that you have them, so that it can identify and use a proper corresponding index. To explore how indexes are being used, you can generate the plan document for any query by preceding it with the explain keyword. The server will return information including whether it is relying on the primary index or one or more specific indexes. It's also very easy to display this information in the query workbench. Easier, in fact, with tools to change the display sequence and zoom level, as you'll see in demos and labs ahead. As you know from other courses, Couchbase spreads documents across data nodes, even though, from the perspective of your code, each bucketful of documents is treated as a single entity. Now, similarly, indexes can be partitioned across index nodes, when appropriate, yet still treated as a single entity as well. Couchbase 5.5 can automatically partition indexes based on hashing values from a specified field. Doing so can solve capacity issues for very large indexes, simplify the complexity of querying manually partitioned indexes, and speed query performance because only part of your index must be used by corresponding queries. If a query includes a predicate matching the partition field for a matching index, then only the relevant index part will be used. If an otherwise matching query matches an index but does not include the partition predicate, then the entire index will be consulted for this query, as you'd otherwise expect. By default, 16 partitions will be created and spread across available index service nodes, or a different number can be manually assigned. Let's jump in and take a look at creating and using secondary indexes a bit. So over here, I'm going to switch over to the Documents view so we can take a look at a user profile document. Now, in the data model for the documents, which you can explore on your own, we have added a type field to each document. It is a recommended practice, although certainly not enforced in any way. So here I've filtered for user profile documents, and I'm going to open up the first one just to note that my user profile documents each have a status field, and then down they have an address object that has a state field. We're going to play with those two fields for indexing purposes here. Go ahead and close this out and run over to the query view. Now in the query view, I've already set these up for speed. I've got a select query, which I'll go ahead and close and run here. And it's taking a while to run. I'm selecting username, status, and the entire address object from the Couch Music bucket, but only where the state is Oregon and the status is active. Well, it took a long time. That was over 8 seconds. We got back 164 documents. Let's take a look at the query plan. Well, there's the reason. It had to use the primary index, which means that a complete bucket scan was performed across all fields to find values matching these two filters. We can do better. Let's go back over to the history view here, and I've got a create index statement. I'll go ahead and close and run that here. Here in the plan view, it'll let me know that the index is being created. Takes a few seconds, and there we go. We have now created an index called IDX state status in the Couch Music 2 bucket, indexing by state and status. Okay. Well, let's see what that does to our query. I'll go back and reselect, close, and run, and yeah, that's different. Now we have an execution time of 16 milliseconds to get those same 164 documents. I can go back to JSON view and see them here. That's quick enough. I can even tap execute a few times here to get a sense of the variations in the execution time for that query. Of course, that depends on local hardware factors and a number of things. It's not in any way directly related to what you'd experience in a production cluster. Now let's take a look at a few other things here. First, I'm going to reverse out the filtering. Just to make a point that we talked about on the slide, that the query planner is smart enough that if I have those fields as filters, the query planner is smart enough to pick up that same index even though I've changed the order of the query. You'd probably expect that behavior, just letting you know that it is there. Now another thing to notice here is with this index in place, if I go over to my Bucket Insights view and look for my user profile type documents, notice I can now see here visually that my state field in the address object is indexed, as is my status field. So it's a good way to know what's happening here without having to jump over to the indexes view all the time. I'm going to go ahead and drop that index because we're going to do something a bit different. Over here I have my state status index. I can click to open it. I could reopen it in Workbench here. I see the text of the create index statement, but I can also just drop it here. I'll go ahead and drop that index. And I'm going to create a different index over here in Query View. Again, I've got it in the history to keep things quick here. And this is going to be a filtered index. I'm only going to index documents where the status is active. This, instead of having status be one of the indexed fields, I'm actually narrowing the entire index so that I only index active documents. Now that I've done that, I'll go back to my history. What I want to do is select here where the state is Oregon. Now I'm selecting for status, but I'm not filtering by status in any way. And so we fall back to the primary index. I don't have the correct query predicates in place to pick up the index that we just created. Now, I could go with a different query that would. Don't want to get too obvious with things here. I'm going to do a few different things here in this part of the demo. I'll select this next query, and what this query is doing, one, it is picking up the index because now I'm filtering both by state and by status, and that narrower index we created of only active documents can now be used. But also, I pulled out the meta object. Let's take a look at what we get from that. So our results for each document come back here. We get the full address object because we've selected a field which happens to be an object, not just a scalar value. But we do have scalar username and status values coming back. And we also get our meta object back here. And we've aliased it as meta to make it easily identified. Might be easier to visualize this data in a table format depending on your background. Interesting to see that we have two levels of tabling. Here's our address column, so to speak, but there are individual nested multi-dimensional columns within it because those are actually objects. Address and meta are objects. And then last here, I'm going to go ahead and drop that second index we just created, but just to be different, I'm going to drop it from nickel, drop index couch music, and then the name of the index to drop, rather than dropping it over in the indexes view. Either way works, of course, and the bucket insights updates accordingly. If I scroll down to my user profile documents, we see that state no longer appears indexed, neither does status. So obviously there's a lot more that you could play with here, but hopefully that's enough to get you familiar for now. So what have you learned? Queries are filtered using where clauses, just as with SQL. Field names are case sensitive, just as column names are for most relational databases. But because Couchbase by design does not slow down your queries with schema enforcement, we assume you know what you're doing and that you want this flexibility. You do need to get your spelling right. As we've seen, a set of commonly typed documents are the functional equivalent of a table, so it's a best practice to add a type field to your documents. You can build indexes for any field or set of fields while narrowing your overall index range using filters, often filtering a given index for a particular document type. Multiple indexes may be picked up and used by any given query, depending on your overall index design strategy. You can explore the query plan easily, either in text or visually in Query Workbench. And very large indexes can be partitioned by a hash of a specified field value. A partitioned index is available for all relevant queries, but queries filtering by the partition field will run faster as they will only use the corresponding index part. In this lab, you'll get to work setting up some indexing and running related queries. Be sure to play around and experiment on your own a bit too. Next up, we'll look at some filtering approaches and output ordering, as well as how to access system data and document metadata.